Welcome. We are going to solve another example on how to see another example on how to solve a differential equation using method of Laplace transforms. So let's predict the question. So the question says, solve the initial value problem. This given question by method of Laplace transform. So usually the first step is to apply the Laplace transform operator on both sides of the equation. So we'll say first, take Laplace transform on both sides of the equation. Of the differential equation, i.e., we'll have Laplace transform of y double prime plus Laplace transform of y prime minus Laplace transform of 2y equals to Laplace transform of minus 2. So that is step one. And then let capital Y of S be the Laplace transform of y. So let's call this one equation 1. Then equation 1 becomes, so we know by definition that this Laplace transform of the second derivative is given by S capital, so S squared capital Y of S minus S y at 0 minus derivative of y at 0. So this is the value of the Laplace transform of the second derivative of y. And this one is given by S capital Y of S and then minus y at 0. And then this one, we can write it as minus 2. So this is the same as when you write Laplace transform of 2y, the same thing as 2 Laplace transform of y. So just be 2 capital Y of S equals to. Now, when you get the Laplace transform of minus 2, you get the answer to be minus 2 over S. So that is step 1. Now, we know what the value of the function is at 0 and its derivative at 0. So this is the same thing as writing S squared capital Y of S, whereas y at 0, we put 2. So 2 times S is minus 2S. Whereas the derivative, first derivative at 0, we replace by 1. So I'll have minus 1. And then plus S capital Y of S. Whereas y at 0, we replace by 2. So minus 2. Then minus 2 y of S equals to minus 2 over S. So the next thing, let's collect our like terms. So we'll have S squared. This one is S. And then minus 2. Put in brackets. Then you multiply by capital Y of S. Now minus 2S minus 1 minus 2 is minus 3. Should give us minus 2 over S. Now, with this, we can write S squared plus S and then minus 2 capital Y of S We take this one, all these terms to the right will have minus 2 over s plus 2s plus 3. And then it's always good manners to put all these terms over one LCM. So this is like over 1 over 1. So s squared plus s minus 2 capital Y of s equals to LCM is s. So minus 2 plus 4s plus, okay, minus 2 plus 2s squared and then plus 3s. So which implies s squared plus s minus 2 times y of s is 2s squared plus 3s minus 2 divided by s. So this implies that capital Y alone of s will be 2s squared plus 3s minus 2 divided by s into s squared plus s minus 2. Now, it's always good manners when you reach at this point, try to see whether you can factorize these equations and some terms cancels out. So the numerator, we have 2s squared plus 3s minus 2. Product is minus 4. Sum is 3. And numbers will be given by -1 and 4. So that you'll have 2s squared minus s plus 4s minus 2. So when we pair this and this will be s into 2s minus 1 plus twice into 2s minus 1. So this will be s plus 2 times 2s minus 1. So we can write this one as capital Y of s equals to, now I'll have s plus 2 times 2s minus 1. Let's also see whether we can factorize this quadratic in denominator. So s squared plus s minus 2. Product is minus 2. Sum is 1. Numbers, we get minus 1 and 2. So we can write this one as s squared minus s plus 2s minus 2. And then you pair this. So here will be s into s minus 1 plus 2 into s minus 1. So s plus 2, s minus 1 are the factors of denominator, this part. So s into s plus 2, s minus 1. So at this point, you see, we'll have this bracket and this bracket canceling out. So which means capital Y of s is 2s minus 1 divided by s into s minus 1. So at this point, we decompose this into partial fractions. So we can write this one as a over s plus b over s minus 1. So which means 2s minus 1 over s into s minus 1 is equals to, LCM is s into s minus 1. And then s into this would be a into s minus 1 plus b into s. So this is meant to be capital Y of s. So the objective is to get the constant a and b. So 2s minus 1, so this implies should be equivalent to s minus 1 times a plus bs. Now when s is 0, then we'll have minus 1 equals to minus a, which means a is 1. And when s is, to get 0 at this part, you need to fix s to be 1. So it will be 2 minus 1 is 1. 1 times b is b, so which means b is also 1. So therefore, capital Y of s would be given by 1 over s plus 1 over s minus 1. Now these are standard Laplace transforms. And then from the Laplace transform table, then taking, I call this one equation, say 4, taking inverse Laplace transform on both sides of 4, we get inverse Laplace transform of capital Y of s is inverse of 1 over s plus inverse 1 over s minus 1. And so y of t will be given by 1, then plus, this is e raised power t. So therefore, this is the Laplace, this is the solution to the given initial value problem. Thank you.